first thing, gravitational potential. The most important thing in this is the formula itself, but better to know what is the gravitational potential. So let's take gravitational potential at a point. So the gravitational potential at a point in the gravitational field of a body. In the gravitational field of a body is defined as amount of work done in bringing a body of unit mass from infinity to that point. Infinity to that point. Nothing is there. So the meaning of this is gravitational potential at a point in the gravitational field of a body. Okay. Suppose this will be actually applied for the charges. Basically, this will be applied for the charges. If a charge is here, a Q charge is here, we have to bring this charge to here. Or example, a chair is here. Okay, we have to push that chair up to this point, correct? How much amount of work is required? So that's the kind of real-time example which you have to imagine while doing this particular thing. Okay, but the most important thing is it is represented by what? The gravitational potential, that is V. V is equal to minus gm by r. The negative sign shows the opposing in nature, minus gm by r. Once copied down, let me know. So those just joined, I'll just tell you, the gravitational potential is nothing but what? For example, a chair is here. If I want to move the chair here, correct? Some work is to be done, correct? So here the work will be done in the presence of what? Gravitational field. So if I want to move a body from one point to another, but here what is it? From infinity to that particular point. So we don't know one point, it is somewhere in the infinity to some point, we have to move it, correct? That particular phenomenon is called gravitational potential. And no one will ask you define the gravitational potential or anything. Okay, this formula is important. V is equal to minus gm by r. That's it. Yeah. Just copy down V is equal to minus gm by r. Okay. The next one is mostly asked in the entrance examination point of view. Gravitational potential energy. Fine. So same thing only. So here the formula I'll write first. U is equal to minus, U is the gravitational potential energy. Potential energy is basically represented by what? Capital U. This is my U, okay? U is equal to minus Gmm by R. So this is nothing but what? The work done, the same definition. The work done in carrying energy, right? Energy means obviously work done in carrying a mass M from infinity to a point, from infinity to a point in a distance R. In a distance R is called what? Gravitational potential energy. Gravitational potential energy. So guys, basically both the things are what? Bringing or carrying a mass M from infinity to some point, the work done. That's the basic definition of both the gravitational potential. Here energy, that's the other one, it is potential. What is the difference here? The difference is one extra M is included here. That's the only difference. One extra M is included compared to the previous. That's all. And what is the unit of this? Joule or joule, whatever you want to call it, joule. And it's a scalar quantity. So these are some extra information I would like to give you. That's all. It is not there in the book. M will be the masses. That's all. Okay. M will be the mass. That's it. Two bodies will be there. Two masses they will give. So as I told in the last session, for our entrance point of view in class 11th, only the formulas we have to be very thorough. All the masses they will give directly. Clear? Only thing for us is we have to just remember these things and apply. That's all. Direct application. All the questions can be done less than 10-15 seconds. There is not even a single question which has to be done for more than 1 minute or 2 minutes in entrance. And coming to the integration and differentiation question in physics, we won't get even a single question of integration differentiation in physics. Maybe for the board exam we can do that. See, one can be a body mass and other can be a particle mass. Okay, so they can give any other thing here. Clear? They can be any other thing here. One can be a body mass, other can be a particle mass. That's all. So that once we do the problem, then only you'll understand. Yeah, according to the definition, there is only one. So guys, the important thing in this is not a definition. This particular thing, joule and scalar quantity. These three are very important in gravitational potential energy, and you should know what it is. That's all. So coming to the next topic, escape velocity. So this is nothing but the minimum velocity required to project a body vertically upward from the surface of Earth so that it comes out of the gravitational field. And for the entrance point of view, the most important formula, VE, escape velocity is equal to root of 2 gm by r. Also root of 2g r. Here they will give an entrance. M is the mass of the Earth and r is the radius of the Earth. These values they will give in the question. If mass is given, we have to use the first formula. If mass is not giving, then we have to use the second formula respectively. This I will put in the box and keep it. So everyone, please put boxes. Okay. And always maintain a formula sheet. Take an A4 size paper, correct? A thick paper. And write down everything very, what, for example, escape velocity there, V is equal to root of 2 gm by r. Write down everything very small, root of 2 gr. So that class 11 physics, one full formula sheet should be there in the one A4 size thing. So these things you have to carry for your entrance examination. Only the papers for us to just revise the formulas. So if everyone has done this page, I'll go to the next one. Yes, everything is inside the root, okay. The R is also inside the root. See, for example, this R is also inside the root only. Fine, R is also inside the root. So be very careful. So once the class is over, please refer to the NCERT textbook. All of your doubts, you can ask me at the end of session, okay? Don't ask me anything in between the sessions. Don't interrupt while I'm taking the class. Because I'm recording the session, it will be a disturbance for me. I blindly copy it down. Orbital velocity. Orbital velocity. The minimum velocity see, this is the problem. 1 second. So orbital velocity, the minimum velocity required to put the satellite into a given orbit around the area. So it's a minimum velocity required to put the satellite into a given orbit around the Earth. So it is given by V naught is equal to root of Gm by R plus H. This is equal to root of Gr square by R plus H. So we notice something about orbital velocity that I'm not going to write. H. H is nothing but height of the satellite above the surface of Earth. Correct. M is the mass of the Earth, R is the radius of the Earth. That's it. And what is the satellite? You can just read from the book. Okay, that we can all get it. The most important thing for the entrance. Very, very important. First one, time period. T stands for time period. 2 pi root of R plus H the whole cube by Gm. Everything is under root. Second one, for the condition, height of, what is H? H, I told you height of satellite above surface of Earth, right? Height of satellite above surface of Earth less than the radius of the Earth. Capital R stands for what? Radius of the Earth. So that is the same as this, okay? S stands for what? Height of satellite above surface of the Earth. R is what? Radius of the Earth. Fine. M is the mass of the Earth. This M is nothing but what? Our mass of the Earth. So these things you have to keep it in mind. Second condition is if the height of the satellite above the surface of the Earth, I'll write down in words. Height of the satellite above the surface of Earth is less than radius of the Earth. Then what is our formula? Very easy formula for us. This also we have done it in the last. V naught is equal to root of Gm by R is equal to root Gr. Everything is inside the root. This is my second one. Third important point. For the satellite orbiting close to the surface of Earth, same condition is same, only H double less than R, or radius of the Earth greater than the height of the satellite. Time period is equal to root 3 pi by G rho. And the third one is only asked for the advanced. Okay. JEE advanced. The other two formulas are also means or the CET or NEET. Next one, relationship between escape velocity and orbital velocity. VE is equal to root 2 V naught. That's all. The next one, height of the satellite above the Earth's surface. That is H is equal to T square, where T is the time period, R radius of the Earth, small g gravity, acceleration to gravity, by 4 pi square whole power 1 by 3 minus R. So whatever I give in box, that is important. Okay. And I have not seen in any of the paper in the last 20 years about this particular formula. Fine. In any entrance paper, this formula has not been asked, but I'm just teaching you in worst case scenario. If it comes, we have to write it down. So I'm clearly telling you which is coming, which is not coming. Next one, potential energy of a satellite. P stands for potential energy of a satellite. U is equal to minus GMM by R plus H. Fine. Kinetic energy of the satellite. K is equal to GMM by 2 into R plus H. The last one, binding energy of a satellite. What is the binding energy? It is the energy required to remove the satellite from its orbit around the Earth to infinity is called binding energy. So E is equal to GMM. You can put a negative sign showing the opposition. E is equal to minus GMM by 2 into R plus H. So this binding energy is also equal to what? Mechanical energy of the satellite. So I can also write here, this is also equal to the mechanical energy of the satellite. All of these things we will come to know only when we are doing a problem respectively. And next one, the geostationary satellite. So we are all familiar with this particular thing. So it is a satellite, having the same time period as that of the Earth is called geostationary satellite. And one important point which is not there in text 2 that I will write it down here. Okay, so these satellites rotate in the equatorial plane. From west to east. And mainly what is the purpose of this? For communication. Communication purpose. And normally it is in the height of 36,000 kilometers from the surface of Earth.